This is the setup for my summative assessment 2 in my digital electronics 2 subject. There's a 5-volt power supply, a 12-volt power supply, the circuit itself, and a coin acceptor. For my midterm examination in digital electronics 2, this is summative assessment. Um, in this assessment, we're asked to create a source code for PIC microcontroller that will perform the following conditions. Condition 1, when 1 peso coin is inserted in the coin acceptor, the LED at port P0 will toggle. Next, when a 5 peso coin is inserted in the coin acceptor, the LED port P1 will toggle. And lastly, when a 10 peso coin is inserted in the coin acceptor, the LED at port B2 will toggle. The acceptor shall accept both old and new coins. And now let's proceed in making the application. Open MPLAB XIDE. Click on New Project. Standalone project. Select the IC PIC16F18875. Select the XC8. Name it Midterm Exam. And then after a while, we can click the MCC to open the configurator. Save the myconfig file. And we need to add the timers. Go to device resources, timer 0. Find it. Click this add button. Next, these are the settings. Make sure that clock source is T0CK3 underscore pin and time period. For the pin, change the package to this. And as you can see, the timer is automatically pin number 6. So now what we're going to do is open port B0 up to 2. So this is 0, 1, and 2 at port B. And pin mode, let's change these on tick analog for the output and leave it as is for output, and WPU for the timer. Next, um, I'm going to retain the name. This is the system module settings, and let's click generate. Once generation is complete, you head on to source files, main C file. This is where you'll write the code, but you'll need a file here, timer0.c, and here also, pin manager. At timer0.c, we need to take note of this read timer. This is the code that will set the counter for the coin acceptor. So let's take note of that here. Okay, I'm going to use this later for my code. So now let's start to write the code. So here we're going to write the delay for the whole, for the return of the code. This counter is the code that we got from tmr0.c earlier for our declaration of the count. So if count is 1, RB0 will be set to high. Let's put a delay of 2.5 seconds. And here, TMR0 equals 0 will reset the timer and the counter back to 0. So if a 5 peso coin now is inserted, this part of the code, what we can do, what we'll do is toggle RB1. As you can see, it's just the same code as the if 1 peso coin is inserted. The only difference is that RB1 will be toggled the same. Timer and counter will again be set to 0. And then if counter is 10, or if a 10 peso coin is inserted, um, the same code, but RB2 will be toggled. This means this is the third LED with 2.5 second interval still, and of course we need to reset the timer and the counter. Resetting these will make the IC understand what type of coin did you insert, so alam niya kung anong LED ang ilalight niya. Here, as if counter has no um, coin, or this is the reset counter, all of the LEDs will be at 0 or low. Yan. And return. After writing the code, build it, build successful. So next, we're going to head on to the MPLAB XIPE app. Once MPLAB application is finally open, what we can do is change the power settings, head on to settings, advanced mode, password is microchip, and change power to 3.125 and check.
After changing the power settings in the MPLAB IPE, what we need to do is now connect the IC to the ICD2. Lock it, and we're good to transfer the hex file.
Next, let's connect. Let's just okay this. Okay here also. Once it is connected, we can now select the hex file. So to do that, click on browse and find the project name that you named your project earlier. So it is midterm exam. Go to this default production and select the hex file. After that, we're good to program. Hex file loaded successfully. Click program and just wait for the application to program it, and programming complete. This is the pin manager package view. So as you can observe, port 6 is 33, 34, and 35 are open. Port 6 is for the timer. This is for the input of the coin acceptor for the pulses. And 33, 34, 35 are RB0, RB1, and RB2, which are ports B. This will be our guide in constructing our circuit.
For the connection of the circuit, so this is the 5-volt power supply. It is connected to the positive terminal and the negative terminal here. And also, the 12-volt power supply, the negative V is connected to the negative side, and the positive is connected to the coin acceptor itself, positive V. This black wire here is for the ground of the coin acceptor. It is grounded altogether here. Let me just zoom it there. And as you can see, I connected both grounds of the 5-volt connection and the 12-volt connection. Next, this wire here is for the coin signal. This is where the pulses will come from. So this is connected to a 10 kilo ohm resistor, and it is also connected, of course, to the input of the IC. And there's just the usual. This is VDD, VSS, the red wire and the brown wire at this side and at this side. And these three wires here are the output for LED 1, 2, and 3. This is port B0, port B1, and port B2. All of the negative terminals of the LED are connected to the ground. Now let's check for the results of the coin acceptor. Old 1 peso coin, new 1 peso coin, old 5 peso coin, a new 5 peso coin, an old 10 peso coin, and a new 10 peso coin.